Welcome to yet another video of Study Clips Library on the topic of organic chemistry. Have you ever wondered what gives life its incredible diversity? It's the element carbon. Carbon is the backbone of all organic molecules, forming strong bonds with itself and other elements. This allows for an amazing array of complex structures. Organic chemistry is the study of these carbon-containing compounds. From the fuels we use to the food we eat, organic chemistry is everywhere. It's the science behind the clothes we wear and the medicines we take. Understanding organic chemistry starts with hydrocarbons, the simplest class of organic compounds. These molecules are made up of only carbon and hydrogen atoms, but don't let their simplicity fool you. Hydrocarbons are the building blocks for a vast number of important substances, and their unique properties make them essential to our daily lives. Let's dive into the fascinating world of hydrocarbons and explore their different types. Hydrocarbons are incredibly diverse, and they can be classified into different types based on their bonding. The first group, alkanes, are like the well-behaved citizens of the hydrocarbon world. They only have single bonds between carbon atoms, making them what we call saturated hydrocarbons. Think of methane, the main component of natural gas. It's an alkane with just one carbon atom bonded to 4 hydrogen atoms. Then there's propane, used in gas grills, and butane, found in lighters. Alkanes are all around us. Next up are alkenes, the rebels of the group. Alkenes have at least one double bond between carbon atoms, making them unsaturated. This double bond makes them much more reactive than alkanes. Ethene, for example, is a plant hormone that ripens fruit. It has a double bond between its 2 carbon atoms. Propane, used to make plastics, is another example of an alkene. Finally, we have the alkynes, the daredevils of the hydrocarbon family. They contain at least one triple bond between carbon atoms, making them even more reactive than alkanes. Ethine, commonly known as acetylene, is used for welding and cutting metals. Its triple bond stores a lot of energy, which is released as heat when it burns. Imagine walking into a library with no labeling system. Chaos! It's the same with chemistry. We need a way to name molecules so we can identify them easily. That's where nomenclature comes in. For hydrocarbons, the International Union of Pure and Applied Chemistry, IUPAC, has a system. The name tells us about the molecule's structure. For alkanes, the name depends on the number of carbon atoms in the longest chain. 1 carbon, that's methane, 2 carbons, ethane, and so on. For alkenes, we use the same system but change the ending to -ene to indicate the double bond. Ethene for 2 carbons, propane for 3, and so on. Alkynes follow a similar pattern, using the ending -yne. Ethine for 2 carbons, propyne for 3. You get the idea. This systematic naming system ensures that everyone understands which molecule is being discussed, no matter where they are in the world. It's like a universal language for chemists. Section 4. Alkanes and alkenes in action, physical and chemical properties. Now that we know how to name hydrocarbons, let's see what they can do. Alkanes, with their single bonds, are relatively unreactive. They primarily undergo combustion, which is just a fancy word for burning. Think of burning natural gas on a stovetop. That's combustion. Alkanes react with oxygen to produce carbon dioxide, water and heat, which we use for cooking and other purposes. Alkanes, with their double bonds, are much more reactive. They easily undergo addition reactions where the double bond breaks and new atoms or groups of atoms are added. This makes them very useful for making a variety of products. One example is the production of plastics. Many plastics are made from alkenes like ethene and propene. These alkenes undergo addition reactions to form long chains of molecules, creating the plastics we use every day. Section 5. Organic chemistry in our world. Applications and importance. Organic chemistry, with hydrocarbons at its core, is the foundation for countless products and processes that shape our world. From the fuels that power our vehicles to the medicines that keep us healthy, organic chemistry plays a vital role. The clothes we wear, the furniture we sit on, the food we eat, They all have connections to organic chemistry. It's the science behind the colors in our paints, the fragrances in our perfumes, and the flavors in our food. Understanding organic chemistry allows us to develop new materials with improved properties, create more efficient energy sources, and design life-saving drugs. It's a field full of possibilities, constantly evolving to meet the challenges of our ever-changing world. So, next time you encounter a plastic bottle, a gasoline pump, or even a piece of fruit, remember the fascinating world of organic chemistry that makes it all possible. Thanks for watching. Do log into studyclipslibrary.com for interesting video.